An overview of the Big Bang Theory, the prevailing scientific explanation for the origin of the universe. Exploring the origin of the universe. Unraveling the mysteries of emptiness. Welcome viewers to this YouTube program, dedicated to unraveling the mysteries of the universe's origin, and the concept of emptiness. The fascination and curiosity humans have always had about the universe's creation and existence. The central question of the video is, why Big Bang Theory does not explain origin of the universe? Welcome to Dhruvam Knowledge Management. The Big Bang Theory is the prevailing scientific explanation for the origin and evolution of the universe. It is a widely accepted cosmological model, supported by extensive observational evidence and theoretical physics. Here is an overview of the Big Bang Theory. 1. Cosmic expansion. The Big Bang Theory proposes that the universe began as an incredibly hot and dense point, often referred to as a singularity, around 13.8 billion years ago. At this point, all matter, energy, and space were concentrated in a single, infinitesimal point. Initial singularity. The universe is thought to have begun as a singularity, a point in space and time where all matter, energy, and space-time itself were compressed into an infinitely dense state. At this singularity, the laws of physics, as we understand them, may break down, making it challenging to describe the exact conditions. Inflationary epoch, optional. Some versions of the Big Bang Theory incorporate an inflationary epoch, a brief but rapid period of exponential expansion that occurred within a tiny fraction of a second after the initial singularity. Inflation helps explain certain observed features of the universe, such as its overall uniformity on large scales and the absence of magnetic monopoles. Expansion begins. After any inflationary period, if it occurred, the universe started expanding. This expansion is a fundamental aspect of the Big Bang Theory. As the universe expanded, it cooled down. Initially, it was so hot that particles like quarks and gluons could not form stable particles, but as it cooled, protons, neutrons, and eventually atoms formed. 2. Rapid expansion. At a moment known as the Big Bang, this singularity began to rapidly expand, initiating the universe's expansion. As the universe expanded, it cooled down, allowing the formation of particles, atoms, and eventually, more complex structures. 3. Formation of fundamental particles. In the early moments after the Big Bang, the universe was filled with high-energy particles, including quarks, leptons, and photons. As the universe continued to cool, quarks combined to form protons and neutrons, and electrons paired with protons to form hydrogen atoms. In the very early universe, there was a soup of high-energy particles, including quarks, leptons, and photons. As the universe cooled, quarks combined to form protons and neutrons, while electrons combined with protons to form hydrogen atoms. This marked the transition from a plasma-like state to one where atoms could exist. As the universe continued to expand and cool, the photons, that had previously been constantly interacting with charged particles, were able to move freely through space. These photons now form the cosmic microwave background radiation, CMBR, which is a faint glow of microwave radiation that permeates the universe. The CMBR is one of the most significant pieces of evidence supporting the Big Bang Theory. 4. Formation of atoms. The formation of atoms marked a crucial milestone in the evolution of the universe. With the formation of neutral atoms, photons were no longer constantly interacting with charged particles. This allowed photons to travel freely through space, creating what is known as the cosmic microwave background radiation. This radiation is one of the key pieces of evidence supporting the Big Bang Theory. 5. Structure formation. Over time, gravity caused regions of slightly higher density to attract more matter, forming structures like galaxies, stars, and galaxy clusters. The distribution of these structures in the universe is observed to be consistent with predictions based on the Big Bang Theory. As the universe expanded, and matter began to clump together under the influence of gravity, structures started to form. These structures include galaxies, stars, and galaxy clusters. The distribution of these structures in the universe is observed to be consistent with predictions based on the Big Bang Theory. 6. Expansion continues. The universe's expansion has continued since the Big Bang, and it continues to this day. Galaxies are moving away from each other, and this expansion is observable through the redshift of light from distant galaxies. The universe's expansion continues to this day. Galaxies are moving away from each other, and this expansion is observable through the redshift of light from distant galaxies. The rate of expansion, known as the Hubble constant, has been a subject of study and debate in cosmology. 7. Cosmic timeline. The timeline of the universe can be divided into various epochs, including the Planck epoch, the earliest moments, the inflationary epoch, a brief period of rapid expansion, and the formation of galaxies and stars. 8. Cosmic microwave background radiation. One of the most significant pieces of evidence supporting the Big Bang Theory is the detection of the cosmic microwave background radiation, CMBR. This radiation is a faint glow of microwave radiation that permeates the entire universe and is a remnant of the early, hot universe. 9. Formation of light elements. The Big Bang Theory successfully predicts the abundance of light elements in the universe, such as hydrogen, helium, and traces of lithium and beryllium. 10. Evolution of the universe. Over billions of years, galaxies formed, stars ignited, and planets developed. Complex structures, such as galaxies clusters and superclusters, emerged through gravitational interactions. The universe has gone through various phases, including the formation of heavy elements within stars, the birth and death of stars, and the formation of planets, including Earth. In summary, the expansion of the universe, from an extremely hot and dense state, to its current form is a central concept of the Big Bang Theory. This theory explains how the universe began, expanded, and evolved into the vast and diverse cosmos we observe today. The evidence supporting this theory, including the cosmic microwave background radiation, and the observed redshift of galaxies, has made it the prevailing scientific explanation for the origin of the universe. In summary, the Big Bang Theory provides a comprehensive and widely accepted explanation for the origin and evolution of the universe. It describes how the universe began as a hot, dense singularity and expanded over billions of years, leading to the formation of galaxies, stars, planets, and all the structures we observe in the cosmos today. The theory is supported by a wealth of observational evidence, and continues to be a central topic of research in cosmology and astrophysics. The Big Bang Theory does not address the origin of the universe's emptiness, but rather its initial singularity. It's important to emphasize that the Big Bang Theory, despite being a comprehensive scientific explanation for the origin and evolution of the universe, does not directly address the question of the origin of the universe's emptiness, or the underlying nature of the space and time in which the universe exists. Instead, it primarily focuses on explaining the universe's expansion from an initial singularity. Here are the reasons why this distinction is significant. Reason 1. Focus on cosmic expansion. The Big Bang Theory is primarily concerned with describing the expansion of the universe from a hot, dense, and highly energetic state to its current state. It provides a detailed account of the evolution of the universe's matter and energy content over time. Reason 2. Initial singularity. The theory posits that the universe began as an incredibly hot and dense singularity, a point of infinite density and temperature. However, the singularity itself is a mathematical concept, and does not provide insight into the nature of the space, time, or emptiness that existed before, or alongside it. Reason 3. Lack of information prior to the singularity. Our current scientific understanding, based on the principles of general relativity and quantum physics, breaks down when attempting to describe conditions at the singularity. It is, in essence, a point where our scientific knowledge reaches its limits. Reason 4. Philosophical and metaphysical questions. The origin of the universe's emptiness, or the existence of space and time itself, raises profound philosophical and metaphysical questions that extend beyond the scope of the Big Bang Theory. These questions are related to the nature of existence, causality, and the ultimate origin of reality. Reason 5. Ongoing research. While the Big Bang Theory has been extremely successful in explaining various aspects of the universe's evolution and structure, scientists continue to explore the fundamental nature of the singularity and seek a deeper understanding of the universe's origins through theories like quantum cosmology and string theory. In summary, the Big Bang Theory provides a detailed account of how the universe expanded and evolved from an initial singularity, but it does not provide answers to questions about the origin of the universe's emptiness, or the nature of space and time prior to the singularity. These questions remain the subject of philosophical inquiry and ongoing scientific research into the fundamental laws of physics that govern the cosmos. Thank you for joining the program, and for your interest in exploring the mysteries of the universe and the concept of Big Bang Theory and emptiness. Please subscribe and click the like button, and share the video to support further exploration of such profound topics. Dear viewers, don't forget to leave comments with your thoughts and questions for future discussions.